Okay, so a 9-volt battery is hooked up to a 300 ohm resistor. How much current flows through the circuit, and how much power is produced, and how much energy is released in 30 minutes? So let's do given. So I've got some kind of circuit here. I got a 9-volt battery. And I've got so that's V equals 9 volts. And I've got a resistor that's 300 ohms. And an ohm is a volt per amp. It's how much I need 300 volts to get 1 amp to flow through it. So I don't even have close to that. So it's going to be a pretty small amount of current. So what do we want to find? Well, we want to find how much current flows through the circuit. We use a capital I to represent current. How much power is produced, and how much energy is released in 30 minutes. So I'll put U, I don't know, you could use, there's different variables for energy. You can use W for work, you can use U for energy, you can use E for energy. They're all kind of used for that. Let's solve. So what's the relationship between voltage, resistance, and current? Well, that would be Ohm's law. So you have to recognize that the voltage in a circuit will be equal to the current flowing through the circuit times the resistance of the circuit. And since I know the voltage and I know the resistance, I just need to solve for the current. So the current is equal to V over R. So this is be 9 volts over 300 ohms. So what is 9 divided by 300? Anybody get that? 0.03? And is it exactly that, or is there more? Okay. And so now, what units should be on the end here? Amps. Now, how does a volt per ohm give you an amp? I'm going to expect you to know this. I don't mess around. Yeah. An ohm, think about what an ohm is. Look at the quantity chart we made. An ohm is a volt per amp. It's the number of volts you need to get an amp to flow through stuff. So if I was going to have 1 amp flow through this circuit, I would need 300 volts. That's what this is telling you. I need 300 volts to get 1 amp to go through it. But I don't have 300 volts, I have 9 volts. So it's going to be way less than an amp. Well, it is a lot less than an amp. It's 0.03 amps. Hey.
There was a spider.
Oh my God, there was a spider. Okay. Okay. Jump on a table. All right. So this is, so if you have a volt over a volt per amp, the volts cancel. You have 1 over amps, which gives you amps. And what is an amp? What is an amp? It's a coulomb per second. It's how much charge is flowing by every second. Okay, good job, Grant. So this would be current equals 0.030 amps. Now, what's the relationship between power and current and voltage? This is the equation you should remember. P equals the current times the voltage, PIV. Okay? And because this is saying I've got 0.030 coulombs per second going by here. And notice that I went ahead and wrote coulombs per second instead of amps, because I want you to see why we're going to end up with that. And the voltage is, well, we have 9 volts. But what's a volt? If you break down a volt, yeah, it's how many joules of energy is released by the battery or used up by the resistor for every coulomb of charge that flows through it. So if I multiply these together, if I release 9 joules of energy per coulomb of charge, and I got 0.03 coulombs of charge moving by every second, well, that will tell me how much the rate at which energy is being released. And so you have 0.03 times 9, and you get 0.27 watts. A joule per second is a watt. So the power is equal to 0.27 watts. And then, finally, we want to know how much energy is released in 30 minutes. So power is also equal to energy over time. Joules per second, right? So if I want to know how much energy was released, then I just go power times time. Well, the power is 0.27 watts, but what is a watt? A joule per second. But what is time? How much time is going by? 30 minutes. Well, if I plug in, I can put 30 minutes in here. But what's the problem? The seconds don't cancel out. So I have to get rid of the minutes. I have to change the units that I measure time in. 2 seconds. Well, we know that 1 minute is equal to 60 seconds. So that'll cancel that. And so the energy released in 30 minutes is 0.27 times 30 minutes times 60 seconds per minute, and you get 486 joules. So that's the energy that was released by that 9-volt battery in 30 minutes if it was hooked up to this circuit. And this matters. I mean, this might be like a flashlight. You got a little 9-volt battery in your flashlight. You know, this is how much energy it better contain if it's going to be able to last that long. Okay. So, what are the big ideas here? Ohm's law gives you the relationship between voltage, current, and resistance. Power equals current times voltage. And power equals energy over time. And the reason I just wrote the word energy out is because energy, there's lots of different ways of expressing energy. You can call it work, potential energy, sometimes just E for energy, that's usually used for mechanical energy. So I just wrote out the word energy because hopefully that'll make more sense. It's really chemical potential energy that is getting dispersed as heat and light and work by whatever that resistive element is. Okay, and there you go. Any questions? Okay, that is all.